This will be a page 2. Is that the first one? Or 70? I don't know. Is this a 70? I forget as soon as I put it up there. Yes, okay, thank you. All right, yeah, so this can go on page 70. All right, so we are starting trig, and trig will be incorporated in pretty much everything we do for the rest of the year, and everything, or in a lot of what you do for the rest of your math stuff. Especially in physics, absolutely. If you're in AP Physics, you've been doing it, and you may not really know why you're doing what you're doing. You're just doing it at this point. So that's a shame because our courses don't really line up, but they kind of really can't. So you'd be much better off in physics, I feel, if you took it after pre-cal, but it just doesn't line up that way. So it is what it is. But so anyway, so here's the Greek alphabet, because you're going to be seeing a whole lot more of these Greek letters, which you should have seen in chemistry and in physics already, and in geometry. In geometry, you do a very little bit of basic trig, basic right triangle trig. So let's just talk about the Greek alphabet real quick. So there's a whole little story about the Greek alphabet. If you want to read it, I'm not going to read it to you. So I have the capital and lowercase Greek letters here for all of them. You may, at some point in your life, have to learn the Greek alphabet, okay? Where do you see capital Greek letters a lot, just out in the real world? Military? Where else? Greece? Oh, that's a good answer. Nobody's ever told me that. You're right. If you're in Greece, I bet you see these all over the place. What about fraternities and sororities? Yes? Okay. So it's possible if you decide to rush for a fraternity or sorority that you're going to have to learn the Greek alphabet so that you know what's what, but whatever. I had to learn it in college. I took more math classes than you could probably imagine even exist. That's what happens when you get a math degree, but I don't even remember what class it was, but I had to memorize this at some point. So I had to come up with something. I have a little song I'm going to show y'all in just a minute. Not what I learned, but I learned something myself. But I had to know the capital, the lowercase, how to write them, how to pronounce them, what they were called, all that kind of stuff. So alpha and omega, the beginning and the end. It's like A and Z of the Greek alphabet. Beta, probably have seen that before. It looks like a capital beta. These just like A and B, but then this looks like a funky B. Gamma, there's gamma rays. Delta, I'm sure you should be familiar with the capital delta. What does that mean? Change, very good. Maybe you probably didn't even know that there was a lowercase or that was the capital. Then epsilon, there's 2 different ways to do the lowercase. Zeta, eta, theta. Now theta is going to become a big part of our lives here. Your default unknown algebraically is usually x. Well, not usually, it is. The default is x. Doesn't always have to be x, but it's x. And then after x, if x is used, then we usually go with y and z, right? Or we can go with whatever else. Your default for an unknown angle is theta in big boy and girl math, okay? So it's theta, and then after theta is used, then it's usually like alpha and beta. But again, you can use, I would say, almost anything, but not anything would make sense. Delta wouldn't make any sense because it means change, right? Pi wouldn't make any sense because it has a different meaning. So some of the variables have already been assigned values. If it hasn't, then you can use them as variables. All right, or if you're in stats, anybody here in AP stats? Okay, because you're going to see some of these funky things in there too. Then iota, kappa, lambda, mu, nu, psi, omicron, pi. You probably didn't know, most of you anyway, that the pi symbol that we use is the lowercase pi. This is what the capital pi looks like. That's why if you see it with fraternities or sororities, it looks completely different because it's the capital pi. Then rho, sigma, tau, upsilon, upsilon, and phi or phi, chi, psi or psi. So it's kind of like tomato, tomato. You might hear it pronounced differently depending on whatever. And sometimes there's more than one lowercase, and then of course omega. So I just wanted you to have it. I wanted you to know what they were called, how to say it, what it looked like, just so that you have the information. I'm not going to make you memorize it, but it's there. And if you want to read about it, it's interesting if you find that interesting. I am, however, going to make you listen to the Greek alphabet song. So imagine that you are a little toddler in Greece, and you're having to learn your Greek alphabets, just like we had to learn A, B, C, D, right? So here is this. Or if you ever have to learn it for whatever reason, then maybe this is the way it would help you learn it. Oh, hang on. It would help if I turn the sound back up. Sorry, I turned it down because I haven't turned my notifications and stuff off now. There we go. Alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, then there's kappa and lambda, mu and xi, omicron and All right, so that's the whole Greek alphabet. I do have a question, though. I'm just curious. Do y'all know who that is? Is who? Anybody? It's okay if you don't. It's Fat Albert. Y'all heard Fat Albert? Okay, it's from a cartoon in the 70s, which was actually very, very funny. But when it goes, hey, 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 that was his catchphrase. But it was an old cartoon from the 70s. It was a pretty good one, too. All right, so that's Fat Albert. I don't know, MacArthur, is that who you said? Oh, Big Arthur, okay. All right, so let's get back over here. So that's it for the Greek alphabet right now. Let's talk about, before we actually start the notes. So in geometry, you did basic right triangle trigonometry. And it's all based off of right triangles. However, you can apply trig to triangles that are not right triangles. We will eventually get to that. Right now, we are still focusing on right triangles and the right triangle side of things. Just because you did it doesn't mean that you understood what the ratios meant and where they came from, right? So you set up ratios, you push buttons on a calculator. Is that correct? You know how to set them up, and that's fine. That's what's expected of you in geometry. There's absolutely nothing wrong with it. So I want to kind of explain to you a little bit how this works and how it's different than other triangles that you've had. So you don't have to draw this, just stay with me. All right, so first of all, this is a right triangle. I know it's a right triangle because it has a right angle. If I have a right triangle, my right triangle has a hypotenuse. How do I know which one is the hypotenuse? One is not a leg, and I know y'all are doing opposite of what? You're right. Opposite of the right angle, right? So this is my hypotenuse right here. So good job not saying the longest side. Is it the longest side? Yes. How do I know that if I don't have any side links, right? So if I don't have any side links, I don't know which one's the longest side. I can't go by the way it looks. The hypotenuse is always across from the right angle. You have to know how to identify the hypotenuse or you're going to be in a world of hurt. Okay, so got the hypotenuse. I'm just going to assign some values here. I've got 3, 4, and 5, okay? And that's a Pythagorean triple. It works with the Pythagorean theorem. So there's one triangle. So I'm going to draw another triangle. And I'm going to make this one 6, 8, and 10. Tell me how these two triangles are related to each other. They are similar. How do you know that they are similar? Very good. The sides are proportional. What is my similarity ratio? 2 to 1. Okay, so if I double all these side links, I get these side links, and so they are similar, right? Similar means the same shape, different size. So it's not like my triangle got tall and skinny or anything like that. It's the exact same shape. It was just blown up proportionally, right? Great use of those words and stuff there. All right, so then if I do another one, let's see. Is this one similar to the other two? Yes, okay. So if I have similar figures, those figures, because they are the same shape but a different size, they all have congruent angles. So these angles and these triangles all have to be congruent to each other. Okay, does that make sense? All right, and then the similarity ratio here, this will be 3 to 1, right? And we do that by saying, like, 10 over 5 is 2, 6 over 3 is 2, 8 over 4 is 2. If I get the same number all 3 times, I know that they are similar, and that's my similarity ratio, right? So with trig ratios, because they are ratios, which again are fractions, but we're not going to put 10 over 5, you're not comparing two triangles to each other. All triangles that are similar to this one all have the same angle measures as this one, right? So they all have the same trig ratios. And so the way we do those is, let's say I took the hypotenuse, which is 5, and I'm going to put it over this side length, which is 3. I get 5/3. If I do that here, I'm going to put 10 over 6, and that gives me 5/3. I do that here, and I get 15 over 9, and that gives me 5/3. Okay, does that make sense? It should be kind of obvious that that's going to happen, but all right, so that's 5/3 is one trig ratio for these angles. We'll talk about which one it is and all that kind of stuff in a minute. I could take 4 and put it over 5. So if I did this and I'd put 8 over 10, I get 4 over 5. And then here, I'm going to put 12 over 15, and I get 4 over 5. And you can do this same thing with any two sides, and either one on top or bottom, it doesn't matter. You come up with 6 different ratios, right? And they'll all be the same in all 3 triangles. Those are your trig ratios. What that's saying is, regardless of the size of the triangle, the ratio of the sides, give you a specific number, and it's related to these angles. That's the magic of the calculator, that it will give you the angle measures, okay? So if I found an inverse sine function of this, it would give me whatever the angle measure is of whichever one I'm trying to find, okay? So that's how the trig ratios are different than similarity ratios. They are ratios among one triangle, okay? But we're not going to use a calculator on this for a very long time, right? Because we're not interested in the side lengths and the actual angle measures right now. We're interested in how these sides are related to each other, okay? Are we good at this point? All right. So let's go back over here. This is going on 71. Oh, look at that. I didn't even erase it. Let me make sure I erased the other page. Oh, I did. I just must have got sidetracked there. Okay. So on page 71 when we're done. All right. So we have trigonometry. Trigonometry literally means triangle measure. That's what it means. Trigonometry, triangle measure. It's the study of the relationships among the sides and angle measures in triangles. Right, triangle measure. So we have trig ratios. So a ratio mathematically is a fraction. Okay. So we're going to come up with our little fractions. Trig ratio compares the lengths of two sides with respect to an acute angle theta in a right triangle. So again, even though we're going to be able to apply this to things that are not right triangles, it's all based off of our right triangles. And it says acute angle. Well, if I have a right triangle, I have a right angle. That's what makes it a right triangle. That's not an acute angle, but the other two angles have to be an acute angle. So it's always related to the acute angles. The only thing the right angle does is let us know we have a right triangle. Okay, so then we have trigonometric functions. A trigonometric function is a rule defined by trigonometric ratios. So you'll hear me use the words trig ratio and trig function kind of interchangeably. Kind of the same thing, right? So when you did this in geometry, you had a little acronym that helped you set this up correctly. SOHCAHTOA. Look at that. Okay. So SOHCAHTOA. And just knowing it is not enough. You've got to be able to spell it correctly to use it. So SOHCAHTOA. SOHCAHTOA. So when I was in high school, we may have done some trig in geometry. I just don't remember. My first memory of doing it is in pre-cal. And my pre-cal teacher was very straight-laced, very dry sense of humor. Like, he was an amazing teacher. I loved him, but like he never really got off topic or, anything like that. But he told us this long, drawn-out, very good story about Chief SOHCAHTOA, some Indian chief that had to do with this to help us remember it or whatever. So when I started teaching, I was like, you know what? I think I want to use that story. So Google was a thing when I started teaching, and I looked for it, couldn't find anything remotely like what I remembered it was. Maybe I just don't really remember what it was. I just remember that he did it. And so then I was really impressed because I feel like he probably made that up, and then that was really outside of his comfort zone, so whatever. But I have a really good story that I'm going to share with you about SOHCAHTOA that I don't think is the same thing. But it requires us to kind of learn a whole lot more trig because it has a lot of play on words in it. And once you learn it all, it's very well written. So we'll get there at the end. Okay, so SOHCAHTOA. So it is related to one of the two acute angles. You pick one. It doesn't matter which one. It's usually really obvious which one, like maybe it's already labeled for you, or it's an angle you're looking for. It shouldn't be difficult to figure out which one. This one's labeled as theta. This is going to be your angle. Okay. It's going to help some of you, not all of you, and you don't all have to. Some of you will need to draw arrows to get these things labeled correctly. Across from theta is your opposite side. That's why it's called the opposite side. We're going to label it as O. Across from the right angle is the hypotenuse. We'll label it as H. And then attached to theta, not the hypotenuse, is the adjacent side. So I basically label mine the exact same order every single time. I do the opposite, then the hypotenuse, and the adjacent. And the more consistent you are, the less likely you are to make something up. Because if you don't label them right, you're not going to get any of this right. Okay? So the next thing is, you learned in geometry 3 trig ratios. There's actually 6. But once you get 3 of them down, bless you. The other 3, piece of cake, because they're just reciprocals, so it's no big deal. But sine, cosine, and tangent you should already be familiar with. And we abbreviate it as sin, cos, and tan, but we do not say sin, cos, and tan. We say sine, cosine, and tangent. That's the way abbreviations work. Okay? Think about that. If you go to the doctor, and your doctor's name is Dr. Smith, and you walk in there and you say, well, hello, Dr. Smith. You kind of sound like a dir, right? Like that's not, it's doctor. I know it's spelled dir, but you say doctor. This is spelled sin, but you say sine. You say cosine. You say tangent. Don't sound like a dir and say them right, okay? Well, don't and say them wrong. Make sure you say them right is what I was trying to say. Okay, so the way SOHCAHTOA works, your sine ratio, sine of theta, sine of some angle, you always take the sine, cosine, or tangent of an angle. It's equal to a ratio of sides. This means sine is opposite over hypotenuse. So sine equals opposite over hypotenuse. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Tangent is opposite over adjacent. It's that easy. Okay? Then the other three are just reciprocals of those, but you got to know which one is which. So sine and cosine are not reciprocals of each other. However, tangent and cotangent are. So tangent and cotangent are reciprocals. So if tangent is opposite over adjacent, cotangent is adjacent over opposite. There's no acronym for the reciprocals. I guess you can make one up if you want, but the easiest way to do it is just to know these and then know that you take the reciprocal. I mean, that's the best way to do it. The reciprocal of sine is cosecant. So cosecant is hypotenuse over opposite. And then secant is a reciprocal of cosine, which makes it the hypotenuse over adjacent. So one thing to keep in mind when you're trying to remember how the reciprocals work, first of all, know that tangent and cotangent go together. It's the easiest thing. And then keep the other ones straight. In every pair, so these are all reciprocals in each row, there's only one co in each pair. So cosine and cosecant aren't reciprocals. There's a co in each pair. And then it's going to be pretty easy for you to keep up with. Okay? What questions you got? All right, so we know they're reciprocals as far as the ratio of the sides. They are called reciprocal functions, okay, reciprocal functions. So it says because the cosecant, secant, and cotangent ratios are reciprocals, they are called reciprocal functions. So even though we know cosecant is hypotenuse over opposite, cosecant is the reciprocal of sine, so I can also look at it as 1 over sine theta. Secant would be 1 over cosine theta. And cotangent would be 1 over tangent theta. Any questions at this point? All right, so right now we are only finding ratios. That's all we're going to do. We're going to find ratios. We'll talk about why we care about them and stuff once we can know we can find them correctly and whatnot. And it says to find the exact values of all 6 trigonometric functions of theta. So here's theta, mark my angle. Across from theta is the opposite side. Across from the right angle is the hypotenuse. The other one's the adjacent. So I set up my ratios. I know sine is opposite over hypotenuse, so that's going to be 4 over 4 square roots of 5. Then I need to fix that. Can I cancel the 4's out? Yes, so that leaves me with 1 over the square root of 5. Can I leave it like that? No, I have to rationalize. So if I have 1 over the square root of 5, to rationalize it, I got to multiply it by the square root of 5 over the square root of 5. That becomes the square root of 5 over 5. This becomes square root of 5 over 5. Can I cancel those 5's out? No, because then what would I be left with? A square root sign and a fraction bar? It doesn't make any sense. So we're good? Got to be able to rationalize and simplify your fractions. Cosine is adjacent over hypotenuse, so that's 8 over 4 square roots of 5. I can reduce that to 2 over the square root of 5. Can't leave it like that, so I've got to rationalize, and that's going to become 2 square roots of 5 over 5. Tangent is what over what? Opposite over adjacent, so that's 4 over 8, which is 1/2. What questions you got? We all good so far? Okay, so now we're going to move on to cosecant. Somebody says something. I know that cosecant is reciprocal of sine, so it's hypotenuse over opposite. If all I was doing is cosecant, I would have to start from scratch. But I have sine, so I know that this is just the reciprocal of sine. I can pick one of, all three of these have the same value. If I just pick this one and I take the reciprocal of that, I get the square root of 5. I don't have to do any work. Secant is the reciprocal of cosine, so that's just going to be square root of 5 over 2. And then cotangent will be 2. What questions you got? We good? All right. All right, so number 2. We do the same thing. We're going to need all 6 ratios. What are we missing? A hypotenuse, okay? So I need to find my hypotenuse, right? So this will be, because this is, go ahead and do this. This is my opposite. This is my hypotenuse. This is my adjacent. I don't have my hypotenuse. I need that. So how can I find that? Pythagorean theorem. So I'm going to take 6 square roots of 3 squared plus 6 squared equals h squared. What is wrong with what I just wrote? What do I need? Parentheses. I forgot this is my spring class. Okay. Parentheses. So when I square 6 square roots of 3, I square the 6 and get 36. I square the square root of 3 and get 3 plus 36 equals h squared. Well, what's 36 times 3? 108. So I get 108 plus 36 equals h squared. 144 equals h squared. H equals 12. Technically, it's plus or minus 12, right? But does the minus 12 make any sense here? No. So it's just going to be 12. All right. So then I find my sine ratio. That is opposite over hypotenuse. So that is going to be 6 square root of 3 over 12, which reduces to the square root of 3 over 2. Cosine is adjacent over hypotenuse. It is 6 over 12, which is 1/2. Tangent is opposite over adjacent, so that's 6 square roots of 3 over 6, which is just the square root of 3. Any questions at this point? All right, so when I go to cosecant, it's the reciprocal of sine. I think I want to pick this second one to take the reciprocal of, so I'll have 2 over the square root of 3. When I rationalize, what do I get? 2 square roots of 3 over 3, right? You shouldn't have to go off this side and do the work anymore. You should just be able to do it. The reciprocal of 1/2 is 2. The reciprocal of the square root of 3 is 1 over the square root of 3, and then what does that become? Square root of 3 over 3. Any questions at all? Okay, perfect. All right, so now we're going to use, it says to use the given trigonometric value to find the remaining function value. So in order to do this, we need a triangle. So we're going to draw a triangle. It's a right triangle. Other than that, it doesn't matter. I wouldn't draw it too small because you want to be able to label it. Doesn't matter which way it's turned or anything. I'm very consistent with the way I draw mine. And then I pick an angle. I'm going to pick this one. And I'm going to label my sides. This is the opposite. This is the hypotenuse. This is the adjacent. And they give me tangent. Tangent is what over what? Opposite over adjacent. So I'm going to put 7 and 24 here. Now, does that mean that's for sure the side lengths of the triangle this came from? No, but it's the reduced ratio of it. Okay, so then I also need my hypotenuse, so I can do Pythagorean theorem again. So I'm going to do 7 squared plus 24 squared equals h squared. I'm just going to tell you in the end, h is 25 because this is a Pythagorean triple. If you don't know that, then that's fine. You do Pythagorean theorem and you figure it out. All right, so you go ahead and set up your 6 ratios here. Okay, so pretty easy when you don't have to reduce anything, right? We're all good? Any questions? All right, so let's look at number 4. Now I have secant of theta, and I want to find all the rest, so I'm going to draw my triangle. Theta here, opposite, hypotenuse, adjacent. Okay, so secant is not in a fraction, so I'm going to put it in a fraction, 4 over 1. Secant is the reciprocal of what? Cosine, okay? So reciprocal of cosine. Cosine is adjacent over hypotenuse, which means this is hypotenuse over adjacent. So this is going to give me 4 and 1 here. And then I need to do Pythagorean theorem again. So I'm going to get 1 squared plus opposite squared. It looks like 0. We just need to know it's not 0. Equals 4 squared. So 4 squared is 16, so the opposite squared is 16 minus 1, which is 15. So the opposite side is the square root of 15. So sine, opposite over hypotenuse, square root of 15 over 4. Cosine, adjacent over hypotenuse, 1/4. Tangent, opposite over adjacent, that's square root of 15 over 1, so that's just square root of 15. Okay. All right, so cosecant is the reciprocal of sine. That's 4 over square root of 15. So what does that become? 4 square roots of 15 over 15. 1/4, reciprocal is 4. And then 1 over the square root of 15 comes the square root of 15 over 15. All right. What questions do we have? We good? Okay. So we can do these ratios with any triangles, but the ones that we are going to focus on the most, and the ones that are the most important to us, is knowing how to do it with our special angles. So the other thing you did in geometry, right around the time you did trig, was special right triangles with your 30, 60, 90, and 45, 45, 90 triangles, okay? So this is all related to the trig stuff, which is all related to these special angles, which is all related to the values that we're going to use here on out, including into calculus and beyond. So we're going to start with the 30, 60, 90 triangle. So one of the ways so these had some ratios, and we use those to find missing sides and whatnot. So across from the 30-degree angle was your short leg. So label that S. Hypotenuse was 2 times the short leg, and then the long leg was the short leg times the square root of 3. You may have used X's instead of S's, but to me that gets very, very confusing, so I'm a much bigger fan of the S. Okay? So that's your ratio there that we could have used with similar triangles to find missing sides. So we're going to use this to find our 6 trig ratios of the 30 and 60 degree angles. So in order to do this, we're going to say that our short leg, we're going to say it's 1, length of 1, which means the hypotenuse is going to be 2, and this is going to be the square root of 3. Those are the values we're going to use. It's kind of like the reduced values of the triangle. All right, so to find the sine of 30, this is my 30-degree angle. Sine is opposite over hypotenuse. That's 1/2. Sticking with 30, cosine is adjacent over hypotenuse. That's the square root of 3 over 2. Tangent of 30 is opposite over adjacent. So that's going to be 1 over the square root of 3. And then what does that become? Square root of 3 over 3. Okay, so I'm going to mark that out like that's how we got it. But all right. So then cosecant is the reciprocal of sine, so it's 2. Secant is the reciprocal of cosine, so that's 2 over the square root of 3, which becomes 2 square roots of 3 over 3. And then cotangent's reciprocal of tangent, we get the square root of 3. Everybody good so far with where all that came from? Okay, so we're going to stick with that same triangle and do the 60. So sine of 60, that's opposite over hypotenuse. That's the square root of 3 over 2. Then the cosine of 60 is adjacent over hypotenuse. That's 1 over 2. What do you notice right now? They're just flipped. The sine of 30 is the same as the cosine of 60, and same with the others. Okay? So then tangent is opposite over adjacent. That's the square root of 3 over 1. That's just the square root of 3. All right, so cosecant is the reciprocal of sine. Well, I already know that the reciprocal of the square root of 3 over 2 is 2 over the square root of 3, which is 2 square roots of 3 over 3. Secant is the reciprocal of cosine, so that's 2. I don't know why I'm boxing it. And then cotangent is the reciprocal of tangent, so the reciprocal of the square root of 3 is square root of 3 over 3. So we just filled in 2 full rows. Did we use any numbers different in the third row than we did in the first row? No, we did not. Because in the end, we're going to have to know these. You're not going to go home and memorize them. I'm going to give you all kinds of ways for you to know and understand the relationships. But what you have to know going in, so you don't feel overwhelmed going in, is that we have very few numbers we actually remember. We just have to know how they're related to each other. Okay? So it's not like it's an infinite amount of numbers we have to know. There's very few, and they're all very kind of similar to each other. It's not that big of a deal. All right, so now let's look at the 45, 45, 90. So we can label this one L squared root of 2. That's your rule for special right triangles. So if we let the leg be 1, this one's 1, because it's an isosceles right triangle, so the 2 legs are congruent, which means this side is going to be square root of 2. All right, so the sine of 45, well, they're both 45, so it doesn't really matter which one you pick. So I'll pick this one. Opposite over hypotenuse, that's going to be 1 over the square root of 2. And that becomes square root of 2 over 2. Cosine is going to be adjacent over hypotenuse. It's the same thing. It's still just 1 over the square root of 2, so you get square root of 2 over 2. Does it make sense that those two are the same? The side lengths are the same, right? Opposite and adjacent are the same, so they should give you the same ratio. Tangent is opposite over adjacent, so that's 1 over 1, which is 1. Cosecant's the reciprocal of sine, so that's just the square root of 2. And secant's going to have to be the same. And then what's the reciprocal of 1? 1. Okay? So these values here are going to become a huge part of your life. Right now, I don't expect you to just know them, but I do expect you to be able to find them using the ratios. Does that make sense? We all good? Any questions? All right.